Hi, welcome to this lesson on Probability Counting Principles Part 1. Let's have a look at question 6. A piano has the following notes on the white keys, C, D, E, F, G, A, B. How many tunes of 7 note lengths can be composed with those 7 keys if a note can only be played once? Okay, so that means there's no repetition. So if we look at the 7 objects here, you could have 7 notes for the first option, 6 for the second, 5, 4, 3, 2, and 1. And therefore, by the fundamental counting principle, we multiply all these and we get 7 factorial. So what is 7 factorial? That is equal to 5,040 different notes. What if the notes can be repeated? Well, again, 4, 5, 6, 7. Now there are 7 notes for the first option, but we can keep choosing any of the 7 notes in any of the positions. So by the fundamental counting principle, there are 7 to the power 7 options here. Okay, so let's do 7 raised to the power 7. We get 823,543. Okay, so that's the number of 7 note length tunes we can play with those 7 keys if it's repeated. Now, what happens if we repeat the keys like we did previously, but the first and last note must be a B key? So again, that means this first option and the last option when you play it on the piano, the first note and the last note must both be a B. So there are 1 option for each here, 3, 4, 5 keys left in the middle. Okay, and each of those 5 keys can be repeated. So there are 7 options for each of those 5 keys. So by the fundamental counting principle, it's 1 times 7 to the power 5 times 1, which is just 7 to the power 5. Okay, so let's bring up our calculator. 7 to the power 5, that's 16,807 different 7 note length tunes we can play with those 7 keys. Lastly, the tune must consist of 3 A's, 2 F's, and 2 G's. So let's think about this one. We would normally have 7 factorial ways of any of the 7 notes. However, we have 3 A's, we have 2 F's, and we have 2 G's. Okay, so 2 G's, sorry, I meant to write 2 factorial there rather. Okay, so with those identical repetitions occurring, we need to divide them out. So it'll be 7 factorial total ways over that number. So let's get out our calculator and see what that is. So 7 factorial total ways, but we need those 3 A's, we need those 2 F's, and we need those 2 G's. Okay, that'll give us 210 different tunes using those letters, those 3 A's, those 2 F's, and those 2 G's. Okay, so that is how we would apply our knowledge of the different counting principle techniques. I'll see you in the next one.